Hi, good afternoon, all of the B.Sc. third year student. Once again, I welcome all of you to our online lecture. That is the first unit of environmental analysis. First, in which we are learning analysis of water. In last lecture, we have learned about the methods of measurement of water quality parameters, that is what the physical parameters, in which we have already seen the conductance of the water, and today we are going to learn about the pH and total dissolved solid of the water. So let's begin with these topics, that the how you can measure the pH of water as well as the total dissolved solid or is nothing but TDS of water. So first one, that is what determination of pH of water. The definition: what is pH? The negative logarithm of hydrogen ion concentration of water is termed as the pH of water. That is nothing but what? Negative logarithm of hydrogen ion concentration is nothing but pH of water. So pH is equal to negative minus log the concentration of hydrogen ion. So pH of water is equal to minus log concentration of H plus ion in water. So generally pH scale is the what divided into what it is what the from 0 to 14. The pH scale extend over 0 to 14. From 0 to 7 it is acidic. From 7 to 14 is basic, and at the exact 7 it is what the neutral pH is there. Then see how one can measure the pH of water. So the practical pH scale extends from 0, a very acidic pH, to 14, a very basic pH with middle value, that is pH is equal to 7, corresponding to the exact neutral pH. So from 7 to 0, acidity get increased. From 7 to 14, basicity get increased, and exact 7, that is nothing but the neutral one. Then what is the significance of this measurement of pH of water? So it is the measure of acidity or basicity of sample solution, but in fact the alkalinity and acidity of sample solution expresses the total reserve or buffering capacity of sample, whereas the pH value represents the instantaneous concentration of hydrogen ion. So what is the significance? We can determine the instantaneous concentration of hydrogen ion. And method of determination, how one can determine the pH of water. The pH of water sample or sewage sample can be measured. So method of determination of pH of water sample or sewage sample can be measured by colorimetric method or by electromeric method using a glass and calomel electrode system. So for the measurement of pH we use two cells, that is two electrode, that is what glass and calomel electrode, that is one is the reference electrode, one is what the indicator electrode. Then electromeric method or colorimetric method is used for the determination of pH of water. So the colorimetric method using an indicator is suitable only when rough estimation of pH is desired. If we want to measure the pH roughly, then we can use the colorimetric method, but for the accurate measurement or accurate determination of pH of water sample requires the electromeric method using a glass and calomel electrode system is commonly employed. So we use the electromeric method for the determination of pH, for the accurate measurement of pH of water. So what is the principle behind the determination of pH by electromeric method? The several electrodes have been suggested for the electromeric method of determination of pH of water. So but we use the glass and calomel as a coupled electrode. Though the hydrogen gas electrode is recognized as a primary standard, the glass electrode in combination with saturated calomel electrode as a reference electrode is the most common electrode system used for the determination of pH of water. As suggested, that is the standard hydrogen electrode, that its potential is 0. Actually, what 0? Also, we can use the primary electrode as what the hydrogen electrode, but generally we use the calomel electrode with the combination of glass electrode for the measurement of the pH or determination of the pH of the water. The glass calomel electrode system is based on the fact that a change in pH of one produces an electrical change is about what 59.1 millivolt at 25 degrees Celsius. So change in one pH results in the change in electrical charge is about what 59.1 millivolt at 25 degrees Celsius. So what is the method? For the determination of pH of water sample, a pH meter, glass calomel electrode system, an appropriate pH standard buffer solution, either PH4 or PH7 or PH9, and water sample are required. What is the requirement for this electrometric method? We require the gas electrode, gas calomel electrode, as well as what buffer solution of PH4, PH7 and PH9 for the standardization or calibration. Before the measurement of pH of water sample, the pH meter is to be calibrated against a standard buffer solution of known pH 4 or 9 or 7 with the help of keeping the electrode in the buffer solution, and by adjusting the pH reading to 4, 7 or 9, we can calibrate the pH meter before determining the pH of the water solution. Then step first for the calibration of pH meter. Depending upon the probe range of pH of water sample, a specific pH standard buffer solution is used for the calibration of pH meter. For the range of 0 to 5 pH, a standard buffer solution PH4 is used, which is prepared by using potassium biethalate is used. For the range of 5 to 8 pH, standard buffer solution PH7, which is prepared by using potassium hydrogen phosphate and sodium hydrogen phosphate is used for the preparation of PH7 solution. For the range of 9 to 14 pH, a standard buffer solution 9, which is prepared by using sodium tetraborate. So depending upon the pH range of the water, or what type of water you are going to analyze, what range of water you are going to analyze, so select the pH solution, that is buffer solution, and measure, standardize or calibrate the given pH meter. As we using the water which pH is from 0 to 5, then use the buffer solution, that is what has have pH is 4, and if you are going to measure the pH of water, the water pH is in the range of 5 to 8 pH, then use the buffer solution of PH7, which is prepared by using potassium hydrogen phosphate and sodium hydrogen phosphate. And for the range of 9 to 14, use the pH9 solution, which is prepared by using sodium tetraborate. Then Na2 B4O7 10H2 is the sodium tetraborate. Standard buffer solution of pH 479 is taken in a beaker in sufficient quantity. A glass electrode and a calomel electrode are dipped in it, and either leads are connected to the appropriate terminal of pH meter. Then the calomel to negative terminal and glass to the positive terminal of pH meter. The pH meter is expected to show a reading of pH 479 accordingly. Otherwise rotate the calibration knob of pH meter such that the pH meter shows the correct pH, that is 4, 7 and 9. no pH meter is said to be calibrated. So the no the pH now the pH meter is said to be calibrated. What is the procedure? Take the buffer solution which has the pH of 479 is taken in the watt beaker and sufficient quantity. The glass electrode and calomel electrode are dipped in it, and their leads ends of this terminals of this electrode are connected to the appropriate terminals of pH meter, that is what calomel to negative terminal and glass to the positive terminal of pH meter. The pH meter is expected to show a reading of pH 479 accordingly. If the pH meter is not showing that reading, then adjust with the help of what calibration knob pH, depending upon which type of the buffer solution is used. If you use 4 pH buffer solution, then adjust knob to the 4 pH reading, and then it is what said to be the instrument is get calibrated. The next step, second step, is a measurement of pH of water sample. After the calibration of pH meter in the step first, replace the standard buffer solution in the beaker with the water sample. Ensure their leads are appropriately connected to the pH meter. Now to measure the reading on the pH meter which indicates the pH of the water sample. So what is the procedure? Measurement of pH of water sample. After calibration of pH meter in step first, replace the standard buffer solution in beaker with the what in place of this buffer solution keep a water sample, which is what which we will have to measure the pH of that sample. Then ensure the glass and calomel electrode are properly immersed in the it and their leads are appropriately connected to pH meter on the positive and negative terminal. Now measure the reading on the pH meter which indicates the pH of the water sample. So this is about the what measurement of pH of water sample. Then next one is the measurement of total dissolved solids of a water sample. So TDS is nothing but the total dissolved solid or salts present in the water are called as total dissolved solid of water. Or the dissolved salts present in the water sample include phosphate, sulfate, chlorides, carbonates, bicarbonates, nitrates, and other soluble salts of mainly calcium, magnesium, iron, manganese, and sodium, potassium, cations, and other metal cations. So the TDS of water is expressed in milligrams per liter or ppm. So what is the TDS? The total dissolved salts present in the water are called as the total dissolved solids of water. So the dissolved salts present in the water sample include phosphate PO4, sulfate SO4, chlorides Cl-, carbonates CO3-, bicarbonate HCO3-, nitrates NO3-, and other soluble salts mainly Ca+2, Mg+2, Fe+3, Mn+2, sodium Na+, and K+, cations and other metal ions. So the TDS of water is expressed in the milligrams per liter or parts per million. Then determination of total dissolved solids. The definite volume of water sample containing dissolved solids is taken in a pre-weighed china dish. The china dish with water sample is then placed on hot water bath so that the water is evaporated completely by a slow process. After slow and complete evaporation of water, the dissolved solid present in the water remains at the bottom of the china dish in the form of TDS residue. Actually, the evaporation of water in china dish is continued till a constant weight is obtained. After cooling, the weight of TDS residue is taken from the weight of TDS residue. The amount of TDS in milligrams per liter or ppm in water sample is calculated. The total dissolved solids TDS in water milligram per liter or ppm is equal to weight of TDS residue into conversion factor divided of volume of water sample. So where CF is the conversion factor, and in this way we can calculate the total dissolved solid of water. So how to determine total dissolved solids? It is simple method. Take a water sample in which we are going to measure the total dissolved solids present in the water. Then uh, this China dish is pre-weighed. Take a weight before taking water sample into it. Then the China dish in water sample is then placed on a hot water bath so that the water is evaporated completely by slow process. After slow and complete evaporation of water, the dissolved solids present in water remains at the bottom of China dish in the form of TDS residue. Actually, the evaporation of water in China dish is continued till a constant weight is obtained. After cooling, the weight of TDS residue is taken. From the weight of TDS residue, the amount of TDS in water sample is calculated. So, the amount of TDS, that is total dissolved solid in water milligram per liter or ppm parts per million, is equal to weight of TDS residue into conversion factor divided by volume of water, where CF is the conversion factor. So this is about the measurement of pH, determination of pH and determination of total solid present in the water. So if you have any queries, any doubts about this topic, please uh, put your question in the YouTube comment box. I will try to answer. Have a nice day. Keep watching videos. Thanks a lot.